In this video, we are going to discuss number 7 of the May 2024 paper 2, which is with patterns and sequences. We discussed part A already, and part B, 1 and 2. We're on part B3. Part B3 says that we have to formulate a formula for n. As you can see, we have already done it. So I'm just going to go over it. To obtain this formula, first, find out whether or not there is a pattern, a sequence between successive terms. Here, the diagram number already has a pattern. 1, 2, 3, 4. The difference between each number is always 1. So to discover whether or not there is a common difference between each number, do some subtraction of the following minus the previous. For example, 5 subtract 3 is 2. So try with 7 and 5 to see if you get the same 2. 7 minus 5 is 2. And one more time, 9 minus 7 is 2. So it appears that with each successive diagram, the number of hexagons is increasing by 2. Now, so that 2 is constant. Since it is constant, it can serve as, it can take the role as a gradient of a straight line, if you want to put it that way. Y is equal to mx plus c. So m here would be 2. That 2 is constant. So n can be easily multiplied by 2. Now you have to know what number to start with. So what you can simply do is to create a hypothetical diagram number called 0 and get the number of hexagon for 0. For n equals 0. So all you need to do is to subtract the first value you see by that gradient number. So before that 3, there is a 3 minus 2 is 1. So it must have been 1. 3 minus 1 is 2. 5 minus 3 is 2. So therefore, the starting point is 1. And that will play the role as C. So the formula is 2n plus 1. It's like y is equal to mx plus c. And it's a linear expression. Once the difference is common, the expression will be linear. There's another way to obtain this formula by treating it as a straight line, and you can use 2 points, x1, y1, that's 1, 3, x2, y2, 2, 5. You find the gradient and the y-intercept, like how we normally did in coordinate geometry. y2 minus y1 over x2 minus x1, you will get 2. And then you solve for the y-intercept c, you will get 1. That's another way to do it. For the number of sticks, you apply the same strategy. See if the difference is common. If it is common, then you can treat it as a gradient. 23 minus 15 is 8. 31 minus 23 is 8. 39 minus 31 is 8. So 8 can serve as the gradient. And to know where to begin with, you subtract 15 by that 8 to get 7. So therefore, the expression is 8n plus 7. Again, the perimeter, see if the difference is common. 16 minus 12 is 4. 20 minus 16 is 4. 24 minus 20 is 4. So 4 can serve as a gradient. To find the number to begin with, you subtract 12 by 4. 12 minus 4 is 8. So the expression is 4n plus 8. Again, I repeat, you can treat this as a linear equation. You can obtain 2 points, 1, 3, 2, 5, x1, y1, x2, y2. Find the gradient, find the y-intercept, and then you'll get the same expression. 1, 15, 2, 23, same thing. 1, 12, 2, 16, and you can do the same, and you will get the same expression. But you can also do it like how I just explained it. So that's how you can easily obtain the formula. If you notice, we obtain the formula first, and then we use the formula to help us deduce part 2 and part 1 and part 2. Because this, once you see these numbers are increasing successively like this. This is very easily obtained as explained. So what you need to do is to search for other past papers. This is 2024 and look for number 7s and get number 7s like this. And you can easily solve it and also verify your answer by using YouTube. As you can see, I pasted Terry David, you have Cohen Springer, and you have others to verify your solution. And you also have this platform also you can ask questions to verify your solution. So this is the solution for part 3.